Good afternoon, everyone. Thank you very much for joining today's workshop. I'm Stephen Gao. Today, I'm going to share Ragile's applications and innovation on using SONiC pytest framework. I'm a software test engineer of Ragile Networks. Now, I'm in charge of Ragile white box product test, including test validation and exploring test innovation. My speech will consist of a brief overview of Ragile test team capability and two innovation. First, before the innovation part, I want to share an overview of Ragile's test capability. As a software test department in ICT industry, we focus more on the cost reduction and the efficiency improvement in testing on the premise of ensuring the quality of product delivery. Since 2019, our test team has been tracking benchmark white box suppliers, the service providers, and the community. We combine the external benefits with internal capabilities, and finally, a set of test validation process for white box operation system is formulated. The overall test program is divided into 4 steps: the system design, verification, SDV, quality metric, soaking test, and the delivery interception. The SDV adopts some intelligent tools like pytest framework, the PyTest framework, the Allure report generator to test and output the software result from the application layer to the side layer. After the SDV, we are in quality metric to ensure the product's quality. Then we move the product into our soaking test environment to meet the 24 hours business stability requirements. Long-term stability problems can be reproduced and measurable in the soaking test environment. Finally, through fault drills and on-site delivery interception internally, continuous collection of scenarios, services, and use test suites to solidify the soaking environment. Okay, now we move to the innovation part, which is I really want to share today. The first is the performance optimization of the test framework. When we are using the community automation pytest framework, we are always facing 2 challenges. One is the PDF test of pytest framework sometimes cannot meet the needs of high performance testing for some complex scenarios. One solution is to use commercial test controller like Asia. And they have already put the some test plans into the community, and this is good. But considering SONiC becomes more popular, some players cannot afford the commercial TC. So for these individuals and all the enterprises, it may have a risk of extra cost in the future. Ragile test team is keen to the open source. So what we did, we introduced the traffic generator to the pytest framework. Trax is an open source, low-cost, stateful and stateless traffic generator fueled by DPDK, and this is developed by Cisco. We applied Trax to the pytest framework, and the automatic control of Trax flow, the start and stop flow, and the adjustment of flow parameters are implemented with the Paramiko. We also encapsulate the track streaming function so the pytest scripts can call the track streaming function directly. For the performance satisfaction, tracks can provide 200 gigabits speed limited forwarding with a single core up to 24 megapps, support 10 kilo traffic concurrency and unlimited message types. It also supports BGP, OSPF, and other routing protocol simulations. In this result, Trax seems to be our ideal plugin. So all we need to do is to apply it into automation. We designed the Trax automation, which called by pytest has 3 aspects. The first one is that Trax can configure the parameters of the DOT in pytest and query the result. And Trax is connected to the DOT device through the spare ports, which doesn't affect the existing pytest framework. Python implementations access login, flow control, and other operations on Trax through the Paramik module. With the method of design, Then we can run tracks with pytest framework. We start with the run test shell, and then we call the tracks control module and send configurations and traffic to DUT. These two steps are done in pytest setup module, so they are isolated with the REST test function. After the configuration and traffic built, we run the test function. Here we have two scenarios. One is that the test case needs the continuous traffic, so we move to the assert result after the streaming, or after several streamings. So we stop streaming and assert the test result, and then move to the next streaming, or just release the tracks and end in config reload. So that's the process of tracks called by pytest. So to ensure this performance optimization can be applied into different scenarios, especially some overlay scenarios, we did some protocol packet development to make this method more suitable for the test framework. Until now, we have completed more than 20 common protocol packets, such as PFC and BFD, which can be called directly. For the limit of packet types, we achieve more formats, and based on command keywords, we also improve the detection accuracy and establish a comparison model for different tables. So this is to ensure that the comparison contents of the same tables are not omitted. Here are some case studies we have done by using tracks automation, RDMA, QoS, and COPP. They all are under the test of pytest framework with tracks automation. For this innovation, we developed a combined tool of pytest plus DPDK plus tracks to solve the problem of high performance and complex scenarios in automation, improve the universality of white box test framework. It supports for the establishment of a white box SONiC test framework. So now I'm going to share another innovation, which is called scripts reuse. Let me describe the background first. Why we need test script reuse? The SONiC operation system actually has low stability and strong business relevance. It is easy to introduce low-level problems when there are some large changes or some large updates. For vendors, us, we are always facing the short iteration cycle and fast update speed. And also, the test scripts from SONiC management repo cannot directly cover the customized version. I mean, the shell command differ or the SONiC CLI mode, such customized versions. For example, like Microsoft may have a customized version whose commands are different from the master version. Even for Ragile ourselves, we encapsulate the commands into CLI mode. We don't have a robot to rewrite the test scripts entirely. Hence, the above backgrounds makes us to think how to use one test script to run different SONiC operation system. So before I start sharing our method, please let me explain some key technology. The first one is the MTAGA. It's main tree automatic generation algorithm, which is to extract and store command tree into the database, and the Sera command equivalent replacement algorithm. This can enable different platform commands to be called uniformly. And Docker MySQL is to store and management and is used to store and manage data, including trees and commands. And pexpect is a man machine conversation simulation function. So based on the idea of MIB tree, different commands of different platforms can be unified into one number, so that the commands of the different platforms can be called uniformly. For example, the number path of the command show interface status is 1-3-5. As I said before, MTAGA is used to generate the main tree. It only needs to slightly modify the current test scripts, manually revise the parameter location, and change the mode to the right database mode. automatically complete the command extraction and database MIB tree building on the original framework and record the building path and corresponding commands. After setting up the database, the acquisition and the replacement of parameters will be done by matching different kinds of commands. TokamyCircle is introduced to store management data, and the SQL Alchemy framework is used to operate the database to store commands in the form of a command tree. Path enumeration is used to create the main tree, recording the path from the root node to each child node. So here's an example. The command show username has a corresponding path of 1-2 on the SONiC master version, and the corresponding path of 1-2 in maybe customer A's customized version is show users. So here's the simple progress to achieve the script reuse. We also start with the run test shell. In the base module of pytest, it will identify whether the DUT is using master version or other versions. Then we catch and send the commands followed by SONiC CLI and SONiC shell to MySQL database. The commands will be substituted to the targeted SONiC version equivalently. Then the steps are similar to the original progress. pytest will assert the results. So now I'm going to show you more detail about the internal progress. The beginning steps are described before. When the version is identified as the master version, it will execute the original commands and output the result. When it comes to other platforms or versions, such as Anders operation system running on Ragile platform based on the SONiC, the database will retrieve path from Anders command tree and generate command catch, then searching the related command from the Anders command table in the database and judge whether is the final path. If yes, we do the command substitution and then the rest work. If no, we have to judge the command mapping uniformity. If the path of the original command maps many paths of target paths of Anders, find the related command and do substitution and then rest work. If the target path maps many paths of original master version, we will search the database and check the hit. If not hit, remain the original command and then the rest work. If yes, do the substitution and then the rest work. So this gives the ability of reuse of a test script. We improved the SONiC pytest framework by introducing the MIB tree idea to achieve the script reuse method in different white box products. And reuse the automation test scripts makes rational use of resources, greatly saves the devices and the test cost. And introduce the pexpect function to the pytest framework can achieve the command execution in different CLI mode, and it also meets the test requirements and of different products and more conducive to issue location and analysis. Well, all these methods are based on the exploring SONiC test community. So first, thank you SONiC management repo, and thank you SONiC. And all Ragile networks white box products are applied into the test innovation I described above. So you can find more details of our devices on our website. So if you are keen to our products, please kindly contact our CEO Ethan Gao or product leader Grant Lai. Of course, if you want to discuss more SONiC potential technical cooperation, including the related technology in this presentation or other potential opportunities, contact me directly or our software development engineer Peter Shao. So finally, thank you all for patiently listening my share. Although I cannot be in person right now this year, hope to see you all guys next OCP Summit. Thank you.